Let's review real quick what we have gone over with circles. So we talked about central angles. When the vertex of the angle is in the center of the circle, that the angle, this angle right here, is equal to the intercepted arc. The angle is equal to the arc. Then we talked about inscribed angles. Inscribed, we had two possible things. Inscribed angles means that the vertex of the angle is on the circle. We had that situation, and then we had also this situation where you had one chord and one tangent. So either way, the vertex is on the circle. And so when the vertex is on the circle, the angle is equal to half of the inscribed arc. So the angle is equal to half of the arc. So then today we're going to focus on what happens when the angle is inside the circle. The vertex of the angle is inside the circle. So if you notice, in every other situation, the angle only intercepted one arc, right? Those angles only intercepted that one arc. That was the only one that was caught. Well, the problem is I have this angle right here intercepts BC, and then the vertical angle on the other side, which is equal, so it needs to be considered the same thing. It is also angle 1. It intercepts arc AB. So what do you do when you have two arcs? What do you do with them? Well, what we want to do is basically we're going to average them. So angle 1 is half. So basically any time that the angle is anywhere other than the center, you're going to use half. So it would be half of arc CD plus arc AB. That's what we would use to get angle 1, those intercepted arcs. Then if you want to look at angle 2 has the same situation. Here's angle 2. It intercepts BC, but on the flip side, it also intercepts AD. And so we would do the same thing. We would average those two arcs, AD plus BC. One of the things you can one of the ways you can kind of remember it is I kind of look at it like this is a plus sign. I don't know, so then that maybe kind of helps you to remember to add. You'll have an equation, but I think it's just easier just to know it. So I do think it's helpful to highlight if I've got this angle, then I'm talking about this arc. I've got this angle, which is the same, and even though it's not labeled, you need to recognize that those are the same because they're vertical angles. And so then you would say that angle 1 is equal to half of the sum of the arcs. Okay, so short, I would just write the angle is equal to half the arc plus the arc. That's just kind of a short way to write it. So the arc, which is 120 degrees, plus the other arc, which was 98 degrees. And if you add those two together and divide them by 2, be careful when you do this on the calculator. Make sure that you do 120 plus 98, enter, then divide by 2. Don't type in 120 plus 98 divided by 2. If you do that, you'll get the wrong answer because you're going to add 49 to 120 instead of taking half of 120 plus 98. It does matter, so be careful that you type that in your calculator correctly. So when you do 120 plus 98 and then divide that by 2, you get 109. So a couple of ways that you can think about number 2 is first, let's find the other angle. That's one way to do it. So we have those two. Notice again that we've got the vertex of the angle is inside. And when the vertex of the angle is inside, here's the vertex, then you add them together. So angle X is equal to half of the sum of 53 plus 41. So 53 plus 41 is 47. So that means that angle X is 47 degrees. Well, those form a linear pair. And so if you take 180 and subtract 47, you get that angle 1 is 133 degrees. Now, there's another way to think of it, if this helps too, is 53 and 41 add up to be 94. So if I take 360 minus 94, that would give me the other two angles. what they would be together. So those two angles together are 266. So that would be then that these two arcs, not those two angles, those two arcs together are 266. And so all I have to do then is divide that by 2, and you still get the same 133. So that is another way that you can process through that problem. So basically, I mean, that's like the most important part of what this is. You want to pay attention to where the vertex is and then decide, is the angle equal to the arc? Is the angle equal to half of the arc? Or is the angle equal to half the sum? So when it is inside, the angle is half the sum. When it's on, the angle is half, because there's only one arc. And then when it is in the center, the angle is equal to the arc. Now, a couple little other important things that happen with circles. If you have one circle or two congruent circles, it doesn't matter, and you have two chords that are congruent. So remember, a chord has its endpoints on the sides of a circle. If you have two chords and those chords are congruent, so these two are the same length, then let me name these so they're easier to talk about. We have chord AB and chord CD. So if chord AB, so basically if chord AB is congruent to chord CD, then what is going to happen is that arc AB is going to be congruent to arc CD. Okay, so that's what's going to happen, is then the arc AB is going to be congruent to arc CD. Think about that. If you were to take a paper plate and cut off this piece right here and then copy that same and do that same exact cut over here at CD, then those two arcs, the curved pieces that you have left, are going to be the same size. On the other side, and on the flip side of that, conversely, is that, right, we did if P then Q, then the converse of that would be if Q then P. So if I start with congruent arcs, then I know that the segments or the chords in there would have to be congruent also. So that just is the other way around. If arc AB is congruent to arc CD, so we start with the arcs, then I know that segment AB is going to be congruent to segment CD. So if we look at example 3 about this, so if we have circle A and circle D, two separate circles, BC is, notice it's chord BC is congruent to chord EF, and the measure of arc EF is 125. Find the measure of arc BC. Well, since chord EF is equal to chord BC, then that means arc EF is congruent to arc BC, so arc BC would also have to be 125 degrees. Okay, using that same concept, M is the center of the circle, CDE is 220, so remember C to D to E, so I'm going to go from C to E and I'm going to go there through D. So let's find all of our missing pieces. CDE is 220. Then what I know is that, let me label that, 220. So all that yellow piece is 220. Well, if from E to D, this part right here, if that's 120, then that means C to D must be 100. So I'm trying to decide, is X going to be 10 or is X going to be 14? So it depends on what the arc behind it is. And so now I know I've got 3 of the 4 pieces. So if I add 120 plus 100 plus 70, or 220 plus 70, and subtract that from 360, I find out that this is 70, because I do need the pieces. So I find out that that arc is 70, and so X would have to be 10 because it has the same arc size. So this arc is 70 and this arc is 70, which means that those chords have to be the same length. We can do a similar thing with number 5. I know that if M is the center, I have 250 from E to C. So from E to C, right here, this major arc is 250. And then we have 55 degrees for that other arc. If you add those up and subtract those from 360, you find out that that arc is also 55 degrees. Since those two arcs are the same size, that means those two chords are the same size. So X is also 8.